Hello everyone and welcome back to another video, and today I thought we're gonna take a look at the still very unfinished but yet again working GTX 780 e-Power that I made. So this is using the e-Power 5 on a reference PCB GTX 780. This was a twin frozer and I got this card for pretty cheap as untested actually. But the card was working fine. The only issue it ever had was, you can't really see it, but there's two input capacitors right here that burned for some reason. The card worked fine without them. And yeah, so I always wanted to use the e-Power 5 for a big Kepler, like a GK110 based card like this. And now I've done it. And the reason why I haven't done it before, like I have plenty of these GK110 based cards, is that, well, it only really makes sense when you use it on a reference PCB card. And yeah, all the reference 780s I had before were cards that had, well, problems with the memory of the core. And yeah, like I don't want to e-Power card just to find out it has still memory and core problems. This one didn't. This one just had these two capacitors burnt on the back, probably because someone shorted out something. Other than that, the card worked fine, and the core on this card is really, really good. And even, like, you can see the connections here. They're not that good. Like, this is not finished. I think it has 8 V-core connections, and then 6 or 7 ground connections, and then 2 memory connections, which are the very long ones here. So this is like, it's in the state where I'm like, yeah, it's gonna finish benchmarks, but it probably won't overclock that well. But I tested the card yesterday, and the benchmark actually crashed because I ran it at full tilt. The card actually works better than I thought. So I'm gonna put the phone down in this thing so you can take a closer look at the screen without me wobbling around all the time. So see you soon. So here we are. So I ran Heaven benchmark just because it's, well, you don't have to run it full screen. And yeah, basically you don't run it full screen. Like, I usually run Firestrike to validate things, but Heaven's fine just to put a load on the card. And you can see we are at 1424 megahertz on the core. So the amount of V-core that's going into the card right now is around 1.28 volts. So yeah, that's a pretty good core. Like, I'm under 1.3 volts. And I'm not just a bit, like I'm well over 1400 megahertz, and you can see it's really maxed, like it's artifacting right here. It will not, if I increase the offset by 1, it will not pass. It will go to 1437 and that's the end of it. But it does pass Firestrike with these settings. And I should probably turn off the sound. Why did that turn on again? So, yeah. I'm gonna decrease the core clock slightly, let's say 350. Oh, it just crashed. Yeah, this is 1397. Is that actually the step under it? I don't know. I think Kepler goes in 13 megahertz steps. So there should be one step after this, before 1424. Yeah, 1410. Maybe this holds a little longer while I ramble about the card. So I'm gonna take I'm gonna show some multimeter readings later. First I wanna just a bit talk about the card. So this is the second time I'm trying to use my EVGA e-Power 5 on a yeah, properly use it on a graphics card. I tried to use it on a GTX 580 before, and actually I have that on my wall still. I can get and show that one. And the sound turned on again. So this is the GTX 580 that I tried before you can see how the VRM got removed. And you can here see my very, very bad tries at removing solder mask with a screwdriver. And yeah, so this card also had a pretty good core. It also had the Samsung eDie memory. You can kind of see it here. So this is basically a very good candidate for e-powering. Sadly, this card, I mean, it worked. I had the e-power hooks up. It just didn't run benchmarks because the memory on it, for some reason, got very, very unstable. And I don't really know why. I assume that me scratching away at the solder mask here has something to do with it, because I did that on not just this card, I did that on the GTX 770 Jetstream 2 and also a GTX 680 reference card. And all of these cards, well, at least the 680 and this one would have memory issues. The 770 would just never put out an image ever again. So I think there's something going on with me scratching off the solder mask here that sort of damages the card. And I've stopped doing that. So, yeah. And basically losing this card and like losing all the work that I put into it just made me not want to use the Power 5 for a bit. But then when I got this graphics card, I was like, this has a really, really good core. And it's on a reference PCB. It's Kepler. Like, Kepler is... yeah, Kepler's probably my favorite just GPU architecture. Like, it generally... I just love everything 28 nanometer, but I think Kepler's the best of those. Mostly because the AMD counterpart is more finicky. But that's also very, very fun. So yeah, like Kepler is an architecture that scales with voltage at ambient, as you can see. Like, a 780 comes at like just over 1 GHz stock, so this is actually closer to a 50% overclock than you might think. Yeah, like that's really good overclocking headroom right here. Like it's not that it's like done scaling. I just didn't really bother testing more voltage because the e-power is not hooked up correctly yet. But yeah, so basically I got the card and I was really okay. This really deserves an e-power. And there's like no risk involved with like the card randomly dying because like the core or memory had issues. So yeah, so I hooked up the e-power to this, and I mean here's the card running. So yeah, the plan obviously is to go to town on the card. For now, so basically what I did with the card is, do I have a reference 780 here that I can just show? I do. Mostly, okay. I'm gonna get something else from the wall. So here we have another GTX 780 reference card. It does have a base plate still on it, but this is the same PCB. Like, this one's black, the one that I'm e-powering is brown, but like, apart from the color, the two cards are identical. So what I did to do the e-power is remove the V-Core PWM controller, that's an NCP4206. I also removed the INA3221 over here, which is for power monitoring, and then you can kinda see the supporting circuitry under the base plate here is another small two-phase Richtech controller that's for the memory. I removed all these 3 chips, and then I removed the 6 V-Core inductors and also the 2 memory inductors that are under this sort of opening here and under the base plate. And then I just soldered the e-power wires to the empty solder pads of the inductors. And yeah, that's basically it. So there's a few things I could have done differently. I saw that some people decided to remove all these capacitors right here to get more hookup points for V-Core and ground. I decided not to do that, basically because I wanted to have as much filtering on the card as possible. Like the ePower5 has a lot of output filtering on it, but there's only so much effectiveness that the ePower5's output filter can have when you're connected through a bunch of wires. So I do want to have as substantial as possible output filter on the card itself. And the performance that the card gives right now kind of tells me I did the right thing. Because given the very unfinished state of the card, it actually doesn't drop that much voltage, which I really, really like. So I left these capacitors on the card. And then there's also all of these empty multi-layer ceramic spots on the back, which I'm gonna probably populate with multi-layer ceramics and then just put can-type capacitors over it. And just be very careful not to break them off. And I'm probably also going to put more, like just kind of stack multi-layer ceramics for the memory and maybe do that behind the core as well. Other than that, there's not really a lot of points on the 780 reference PCB that you can use for cap modding, which is another reason why I left these capacitors on, because like, I mean there's a base plate on it, but like, here's the memory already. So you have this bank of capacitors, and then you have this. And basically that's, unless you put something directly behind the core, that's basically all that you can do for v-core output filtering. That's not a lot. So, yeah, I stand by my decision to leave the capacitors on the card. Yeah. So that's basically how I hooked up the card. And I think it is time to... yeah, I think it's time to take a closer look at the card again. Do some voltage measurements. And yeah, just kind of... yeah, take a closer look at the card. Take some voltage measurements to show how much voltage it's dropping. And yeah. So I'll see you soon. I'm gonna rearrange the camera again. And until then... So here we are. Gonna take the ground probe of my multimeter, hook it up to the I/O shield. And now we're gonna check some voltages. So you can see the multimeter right here, which is... well, I can't really get it closer, there's a gap here. So yeah. And we're now gonna test the voltage that goes into the card. Heaven is still running on the screen, and well, this is gonna be kind of difficult now that the camera's in the way. Getting in here. Yeah, this is actually gonna be quite difficult, because usually I have my head right there where the camera is right now. To move some things around. I did not think this through entirely. Damn it, I can't see. Yeah, so that's our v-core. I said 1.28 volts before. This is Heaven. Heaven is not as heavy as Firestrike GT1, so it's slightly higher at 1.3. But that's our v-core directly behind the core. So, yeah. And then the memory voltage, because memory is also e-powered, should be right here. Okay, that measurement's a bit wonky. But yeah, 1.53 around there is where I measured it yesterday. Like the whole it's like wandering around, that's the measurement error. It's not actually going like that. And yeah. So remember those values. And we're gonna take a closer look at the e-power itself. Gonna move the cooling fan for a bit. And well, you can't really see it that well on camera because it like blips. But so v-core is set on the e-power to 1.41 volts. So currently we are dropping 110 millivolts. Oh, see, the camera actually synchronized. Nice. And the memory is set to 1.69 volts. So the memory is dropping a lot of voltage. I am really bad at math. That's like... I mean, it was around 150 millivolts before. Then I increased the voltage even more because overclocking the memory made it draw more power. But yeah. So like the memory is not all that important anyway. Like I'm gonna be hooking up more things to it. But the memory is a very static voltage. Like it doesn't really change how much current it's pulling a lot. So you can just pump in a higher voltage into it, and you can compensate for the voltage drop on memory quite easily, whereas on core you cannot really. Like the core voltage drop changes a lot. So when the card is stock, the core voltage drop changes from 110 to 60 millivolts. So like it depends on clock, it kind of depends on temperature, kind of depends on the benchmark you're running. As you saw before, like in Firestrike, it's 20 millivolts lower than it is in Heaven. Yeah. So we're dropping quite a lot, but considering that the connections look like this, I'm actually positively surprised by the e-Power's performance here. And one thing I also tried is, you can't really see it, it's kind of like in the lower left edge of the e-Power, it's kind of behind the heatsink right now. You can actually hook up, at least for vCore, you can hook up the forward voltage sense. I tried that, but it didn't really work the way I thought it would. Like it compensated for the voltage drop a bit, but not really. So yeah, so I turned it off again because yeah, you just have like two wires hanging off of the e-Power that go like behind the card, and they're very annoying to deal with. So I just decided to get rid of the forward voltage sense, right there. So yeah, that's a closer look at the GTX 780 e-Power. So it's water cooled, of course, also. Yeah, so I really like how it performs with that kind of connection already. Like these should be 8 vCore connections. Then there's a 1 ground on the front. And then on the back there's 2 memory, and everything else is also ground. So that's 1, 2, 3, 4, 5, 6 more ground on the back. So 7 ground in total, 8 vCore, 2 memory. That's not a whole lot. That is not a whole lot, especially considering that a bunch of the ground connections actually go to screw holes, which is not a good thing to do. Like screw holes, yes, they are ground, but it's not like they're connected to a very big, like a very well made and big power strip. So you're gonna kind of have like, more like a literal bottleneck actually. Because whatever you connect, like the ground plane that's connected to the screw hole is probably less wide than the cable you use is. So screw holes don't make very good ground connections. It's just kind of the same way as if the same way that the 780 reference PCB doesn't have a whole lot of points to cap mod. There's also not that many ground spots, so you can kind of see it down there where some of the more connections are. I actually used the ground side of some 12-volt input capacitors, and there are some not like up here. There are some more input capacitors I could use the grounding of. They're just kind of hard to get to between those two big VMEM wires. So yeah, other than that, I could also try to use some parts on the back. Like there's a bunch of capacitors on the back that I could use the ground side of, or just try to connect to the ground parts of the 8 and 6 pin directly. If I find I don't know, if I'm gonna use the same wire, I'll just use a solid core copper wire, or just a very thick wire. Um, but yeah, I mean, that's basically what I wanted to show. Oh no, one last thing that I forgot to talk about earlier. So you see how the memory is only added plus 200. This card is old, but plus 200 on those is, well, I mean, so the curious thing is, there's a bunch of 780 Ti's that get like plus 200. But for 780s, plus 200 is not very good, and basically because 780s come at 3 GHz or 1500 MHz stock, and 780 Ti's come at 3.5 or I think 1750 MHz stock. So basically the 780 Ti already has a plus 500 offset applied to it, while using mostly the same memory chips. They probably have a better bin, but they are probably off the same assembly line. The 780 Ti chips just like have been binned for like more clock, which doesn't mean that the 780 chips can't overclock. And I do think that this card overclocked better when it was on the stock VRM. And that's where the very high voltage drop on the memory comes back in. I'm using two very long wires. I'm using only 2 wires for the memory, and basically I think that's why the memory overclocking on the card is not that great as of now. I think it needs more VMEM, just generally needs more ground for everything. But yeah, like plus 200 is the max it can run. Like plus 300 was straight up. I think I can just demonstrate that. I don't really have anything more to show here. At plus 300, we are gonna very quickly see how the screen just turns solid color and like crashes. Or at least it did that in Firestrike. It might take a while in heaven. Please crash. No? Okay, I'm just gonna you're just gonna have to take my word for it then that it did crash in Firestrike when setting plus 300. And like not just crash the benchmark, you actually had to press the reset button on the system, like everything locked up. So yeah, but here's the first like kind of sneak peek at my 780 Ti e-power. I'm gonna keep working on this, of course, like, yeah. So basically whenever I feel like, it's not like there's gonna be more content in like a few days on it. It's like, especially a project like an e-power, you really only have to, you should only work on it when you really want to. You shouldn't force yourself to do it, because that's when you make mistakes. And you don't want to make mistakes when e-powering. Things die very quickly. So yeah, but I am gonna keep working on this, especially after seeing such good results with a very unfinished e-power. Like, to put it into perspective, I think these connections are like, well, less or just about half of what I would want on the card. Like, I would want to double, if not more, of the connections on the card, is basically the thing. Like, so, as it is right now, there are 6 V-core inductors, and you can see every of these inductor pads has 1 connection to it. I want to put 2 connections on every pad, and then one in the middle. There's a bunch of output capacitors for V-core, actually. I first thought those were memory, but they're actually V-core. Some motorized ceramics that also have 2 connections in them. I might get a 3rd one in there, but I do at least want to double the connectors on the inductor pads. Then for the memory, I'm probably gonna try to attach a connection directly to the memory chips on the back, like using a motorized ceramic capacitors from the memory chips as a hookup point, and then just for ground, I'm just gonna be more ground like everywhere. So yeah, that's how unfinished the e-power is, but it already works really well. Like, yeah. So like, I'm not shoving a lot of V-core into it. Like, a lot of V-core would be like, for my standards, a lot of V-core would be 1.45 volts. I'm currently shoving just about 1.3 into it. And it's already doing over 1400. Like, it briefly even does 1437 when it's like cold enough. It's kind of warm right now. If you keep it under 40, it does 1437 for a bit. Not reliably, but a bit. So between that and shoving more voltage into it and just finishing the E-Power and like cap modding the card once the E-Power is done, I think we're gonna see some really good results from this card. Like, yeah, from what I know, like a good big Kepler does 1400 and a really good one does 1500. And yeah, I am hoping towards it. I can't say I'm really confident that it will, but I'm hoping towards it that it will do 1500 by the time that this E-Power is fully finished and ready to bench. So yeah, that's basically it. I think the video is long enough now. So thank you all for watching. I hope you enjoyed this rather incoherent rambling video. But at least I'm doing some actual overclocking for once, not just showing a card and rambling about it. I'm actually running something this time. So yeah, thank you all for watching. Hope you enjoyed, and until next time, goodbye.